My name is Nick Desbarats. I'm an independent educator and consultant in the fields of data visualization and dashboard design. And in this short talk, I want to talk about what it takes to make great charts. I felt that it was really necessary to create a talk like this because there's a lot of confusion around what exactly are the skills and knowledge that are required to create charts that actually do their job, that answer the question that the audience has, that communicates the insight that you wanted to communicate about the data. And most people really have an assumption that there are basically really only sort of two things you need to know in order to create effective charts. The first, of course, is you have to know how to use a particular data visualization software package like Excel or Tableau or Click or Jump or one of those. And then there is, of course, you have to know the nature of the data, right? Like what kind of data are you going to be visualizing? Is it time series data or parts of a total, that kind of thing. And so, like I said, the assumption that many people have is that if you know these things, then you can create great charts. And I'm going to make the argument that there are, in fact, many other things that we need to know, many other skills that we need to have in order to create charts that are truly effective. But so I want to kind of quickly go through each one of these. So let's start with the one that people think about most often when they think about like, well, what skills are required in order to create great charts. They think, well, of course, we have to know how to use, at least one of these products, right? Like Excel or Power BI or Click or Tableau. And so obviously we have to know how to use one of these products, yeah. But the thing is that people tend to focus almost entirely on this skill when they're looking to develop their data visualization skills or evaluate the data visualization skills of others. Really, they'll often just evaluate how well they know how to use these products. A lot of companies, for example, when they're advertising data visualization roles, if you look at the job descriptions, they're really sort of very focused typically on these skills and using these particular products, right? And so they kind of assume, I think, that if you're an expert user of a data visualization software product, then you must be really good at creating charts, right? But as I see it, though, software expertise is necessary to create effective charts, but it's not sufficient, right? It's kind of like if that's what you're saying, like, being an expert, user of Tableau or Excel makes you great at creating charts. It's kind of like saying being an expert user of Microsoft Word makes you a great writer, right? It's like, well, okay, yeah, I mean, you have to know how to use a word processor to be a great writer, but there's all sorts of other skills and knowledge that you have to have in order to be able to write effectively. And so we all kind of know that this is not true. But what seems to be sort of less well understood is that if you're an expert user of a product like Excel, for example, well, that does not automatically make you a great data visualizer. In fact, unfortunately, it is very possible to be an absolute guru at one of these software products and still create, kind of bad charts. So for now, though, let's look at the other sort of common, element that people understand when, we ask them, what do you need to know to create a great chart, which is basically the nature of the data, right? What kind of data am I going to be visualizing? Like this, for example, maybe we need to visualize essentially how the breakdown of a total changes over time. So here, I guess we're a charity. These are donations, and we have the total donations for 12 months, and then we have them broken down by region here, right? And so we could visualize this data like this, right? Or like this, 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 right? And in fact, this is always the case, right? For any kind of type of data that we might be needing to visualize, there are always lots of different ways that we could actually visualize it. And so just knowing the nature of the data, right? Like, is it time series or breakdown of a total or whatnot, is basically not, it's not enough, right? So like I said, these two are necessary, but they're not sufficient. We also have to know what I call the spelling and grammar of data visualization, which is things like knowing how to choose the appropriate chart type for a given situation, how to choose the appropriate colors for a given situation, and legends and scales, annotations, many other skills, which I'll kind of touch on briefly. And so in this kind of situation, for example, for a challenge like this, how do we visualize this data? Well, there are kind of spelling and grammar sort of guidelines that we can learn that will actually help us to figure out, well, what is the best way to visualize this kind of data in the particular situation that I'm in at the moment. And so these particular guidelines are from a course that I teach called Practical Charts. And I have a number of these. There are 8 or 10 of these kinds of sort of guidelines that I give for choosing chart types and making other types of decisions as well. And so these are things we can learn, and in fact, we kind of have to learn in order to create effective charts. Or another example. So here we have, kind of a poorly formatted quantitative scale here. It's going to demand a fair amount of cognitive energy for people to sort of visually and mentally sort of parse this. Well, if we apply some good spelling and grammar, essentially, right? So we have a well-formatted quantitative scale that uses more intuitive jumps. We don't, like we're jumping it by 5 here, for example, instead of 4. So it's a little bit easier to think about. Obviously, it's less cluttered. Well, it just makes it more cognitively fluent. And that's one of the sort of side effects or benefits of having good spelling and grammar skills and data visualization is that you learn these things. Or something like this. Well, in this stacked bar chart here, certainly, based on these colors, it's not really obvious, like, what am I supposed to get from this? I'm going to have to study it a bit. But just, for example, by using a different color palette, okay, well, even before I've read any of this text, I can see the story here is that this has a lot more of something. And once you start reading, you realize that these are portfolios and this is sort of higher risk. Not so obvious from this color palette, right? And so, again, there are rules that we can learn for, sort of these spelling and grammar rules of data visualization for having well-formatted quantitative scales, for choosing, the appropriate color palette in a wide variety of situations. And there are many other sort of, topics and elements within what I call this sort of spelling and grammar of data visualization. And unfortunately, the software and the nature of the data, it's not going to tell you most of these things, right? The software is not going to tell you, oh, you should be using a sequential color palette in this situation, or you should be using a line chart instead of a bar chart. You kind of have to learn these as this whole other separate set of skills. And it does take some time, right? That course that I mentioned, my Practical Charts course, it's 14 hours long. And so, but if you don't know these basic kind of spelling and grammar rules, then you're going to make kind of spelling and grammar mistakes in data visualization. You're going to have, improperly formatted scales. You're going to choose the wrong color palettes, choose the wrong chart types. And your charts are going to end up being, potentially confusing or worse, misleading, essentially, leaving people the wrong understanding of the data. We also have to, of course, know the audience. You've heard this probably 100 times, right? Know your audience. Well, I want to make that really sort of visceral for you. And also, knowing the domain of the data, i.e., if it's data about insurance, well, you got to kind of know something about insurance. If it's data about sports, well, you got to know something about sports in order to be able to create effective charts based on that data. So like I said, I wanted to try and kind of make this sort of visceral. And so there's an example that I've been using recently to sort of illustrate how important it is to know not just about the software and the data, but also basically what's going on around this data, what's happening in this particular situation. And so the situation here is probably pretty obvious. We have, I guess we're a little chain of stores. We have 4 stores. And so we've noticed as the analyst in this company that, wow, we have a problem, right? Store B clearly is tanking. That's definitely, sort of the key insight here, right? And so you've recently discovered this, let's say, and you bring it to the management team, and you're prepared for lots of oohs and ahs and wow, thank goodness you found this. But instead, you get shrugs, right? People are like, well, duh. Yeah, of course sales at store B are going down, right? We're shutting down that store, right? We're not replenishing its inventory. They have new products to sell. Obviously, obviously their sales are going down, thanks to the news flash, thanks for kind of wasting our time. But then an astute, member of the management team sort of pops up and says, wait a second, we are also shutting down store C, but their sales are not going down. Like, hold on a second. Like we totally expected that their sales were going to go down and they're not. Maybe we should reconsider. Maybe we shouldn't be shutting down store C, right? We're bleeding them dry of inventory and their sales are still, chugging right along, right? And so as it turned out, this was not the meaningful insight of this data. This was. And so how are we going to know that, right? Well, we can stare at the data all day long. We can be the most expert user of Click or Tableau or Jump or Excel in the world, and we're not going to be able to figure this out, right? We have to know what is basically going on with the audience, right? What are they expecting to see in this data, or what would they find surprising? Are there any specific concerns or priorities, questions that they have at the moment that they're going to be interested in? What kinds of insights are they going to find useful as opposed to useless? Because the reality is that most of the insights that we could come up with around a given data set are actually not useful, right? There's only a tiny subset that actually have usefulness. And so you kind of have to know what's going on with the audience in order to know which insights are actually useful. You can't just look at the data as we just saw, right? If you just look at the data, you think that store B was the real story here, but actually it wasn't. It was store C. We also, of course, have to take into account what kind of background knowledge the audience has or is lacking, right? I'm sure you've been in that situation where you show a chart to somebody and they don't grasp it because you kind of assume that they had some background knowledge about this particular situation that they didn't have. The only way we're going to find that out is by actually talking to the audience and learning about them. And also to understand what their level of graphicacy is. Yes, it's a word, right? Literacy, numeracy, and graphicacy, which is the ability to understand graphs. And again, you've probably had the experience of, very different levels of graphicacy in very different audiences, right? And so, there's no point in showing charts to people that they're not familiar with, right? That they just don't know how to read, or at least, if you can't explain it to them anyways. Or, are there certain ways that the audience is used to seeing data of a certain type, right? If it's always presented in a certain order, well, you better know about that so that you don't just, unnecessarily confuse them or force them to do unnecessary cognitive work to adapt to some new convention when there already was one in place. And so again, of course, we're not going to get any of this information from the data. We're not going to get it from the software. We can only get it basically from the audience. And then more generally, really important that we also understand sort of where this data came from. Like I said, if it's insurance data, we better understand something about insurance. How does essentially the domain of this data work? If it's, sports or or healthcare, for example, well, you got to know something about healthcare. If you don't know anything about healthcare, you should not be visualizing healthcare data. And what is sort of common knowledge in this domain so that you don't tell people things that they already know? Or are there, again, conventional ways of presenting data in, engineering or chemistry or whatever domain you're presenting data in? And if there are, you better be aware of them. And so, we have to have knowledge of the audience and knowledge of the domain. If we're lacking these things, then even if we have all of these, our charts are still going to be bad. We also need statistical knowledge, right? So let me give you another scenario. So here we got some data representing the salaries of employees at these three companies. And we want to try to compare them, right? We've been tasked with sort of doing some analysis here. So how do the salaries of these companies compare? Think, well, how can I compare these salaries? Pretty obviously, right? We can just calculate the average. And so if we do that calculation and then we chart it out, we graph it out, well, these companies all actually appear to be quite similar to one another. You barely even need to sort of point that out in the chart. These are essentially very similar companies when it comes to salaries. But then some old geezer like me with gray hair comes along and says, just to be on the safe side, let's try and visualize this as what's called a strip plot. And so in this case, we're actually seeing the individual salary. So each one of these points is an employee salary. Whoa. these companies are not all the same, right? Company A here, well, as it turns out, their salaries are all very tightly clustered around that sort of $60,000 average. But company B, well, most people make less than that, and there's a couple of outliers. And then company C here, well, they were just two completely different groups of people, right? People making, sort of relatively low salaries and people making relatively high salaries. How would you know that this is actually the meaningful insight in this data? Well, you have to just know essentially some statistics, like, don't rely entirely on means. Always look at distributions as well. Don't mistake causation for correlation, because if we don't know these things, then that's going to be reflected in our charts. And it's really easy, of course, to make charts that actually misrepresent reality because, we don't know what the landmines are. We don't know what the pitfalls are in statistics, at least the basic ones. You don't have to be a statistician, but like I said, you got to know where the landmines are. And so 2 great books that I can recommend if you're looking to improve your statistical knowledge: Naked Statistics by Charles Whelan and The Data Loom by my colleague, Stephen Few. Both great books and easy reads. They're not dense statistical manuals. And then finally, the last skill is essentially data handling, data cleansing skills. As a lot of you probably know, if you're visualizing data, you're probably actually spending more time cleaning data and fixing it. And so, if you're always relying on other people to do that, there's really 2 problems there. The first, of course, is that you're going to be a lot less productive, right? If you can't do that yourself, if you're relying on other people. And so knowing even a bit of SQL, for example, or another querying language, or knowing how to use data cleansing tools can be a real plus in terms of your productivity. But more importantly, if you're handling the data directly, you're going to be aware of any limitations and problems within that data. You're going to be a lot more aware of those. And so then you can reflect those in your charts. And so if you're not the one who's actually handling the raw data, then there are probably going to be limitations and issues with that data that you're not going to be aware of. And so then those are not going to make it into the charts. And that could be a huge, huge problem, right? Couple of final thoughts, right? So, those are all of I think there are 7 elements, skills that we need, right? There are a surprisingly broad variety of them that we need in order to create useful charts. Not just useful, but charts that are not going to actually mislead people or misrepresent the data. And so unlike what most people think, those technical skills, right, like the data handling and software expertise and knowing the nature of the data, well, those are just a few of the many types of skills that we need in order to actually create charts that are effective. And those with strong technical skills, right, expert software users, expert kind of data wranglers, but who lack any one of the other types of skills or knowledge, are going to routinely produce charts that are non-useful, right? Or worse, right? Worse, of course, being misleading, or where important insights simply don't make it. They don't show up in the chart because, the whoever's creating the charts just didn't spend enough time understanding the situation of the audience, for example. Or they were lacking some statistical knowledge, and then now they're mistaking causation for correlation or something like that. Like, those are real problems. Like, those are going to lead to bad decision making. And so, of course, the takeaway is that in order to create truly useful charts, we have to develop not some, all of these skills, right? And that takes time, right? Just the kind of spelling and grammar of data visualization, well, like I said, I teach that as a 14-hour course. If you're interested in taking that course, obviously, I welcome you to do that. Most of my workshops every year are private, and so you can contact my colleague Brian, Brian with a Y at practicalreporting.com, which of course is my website. I also offer these workshops a couple of times per year as open registration workshops. The next ones are in December. I will leave it at that. Thanks very much for listening. My contact information, of course, if you have questions or want information about workshops or to check out my blog where I write regularly, can all be found at practicalreporting.com. Thank you very much for listening.